There we go. Good evening, everyone. I'm just getting started for this live stream. Just doing a little bit of prep here. What else? Hope everyone's having a great night. I had a great dinner. I enjoyed cooking some little bit of steak and some butternut squash soup. I really like doing that. I hope your night's been good. Let me know in the chat if you got anything that you want to talk about real quick. Let's see. I don't know. What is going on? Thanks, Steven. Thanks for watching this. Yeah, I'm just gonna hope this should be good. I gotta start cutting some of these into like shorter YouTube videos, like be a little bit more focused. I think that would be helpful. Okay, let's see. So I think I'll start everything now. So good evening, everyone, and thanks for joining me. So, last week I was really just trying to, get started on programming this Elegoo Smart Robot. It's like this little Arduino-based robot with some expansion boards and some different things like that. And there's a L298N chip that is able to program, able to use to go and drive the motors. Got a lot of that figured out. And now I want to do a couple little things. I want to kind of figure out how to control this with the infrared remote. Now, I did that last week a bit, but I want to get deeper into that this time because I think it's going to be interesting to figure out how to solve some of these problems. And I also kind of want to start working on trying to, let's say, get into the mind of a software developer. Figure out how to start writing code in a way that really, a software developer would. Because I think there's a big difference between being a programmer and being a software developer. In my mind, a programmer is a person who takes, software requirements or a description and just starts to write code to fit that. And that's great. But we really like, there's a bit of creativity that's left out of that model of, that idea of a programmer. So I like the idea of a software developer. And a software developer to me is someone who thinks a bit more creatively and says, okay, you've got this desire to go and make this thing work. So let me figure out how we're going to do this. Let me figure out how we're going to break things down and how we're going to turn things into code. And a software developer may not always produce exactly what the customer asked for, but hopefully they'll have produced something that may actually be better than what the customer asked for, because the customer didn't even know that that's what they wanted. So let me get into some of this. And I'm going to start with kind of the boring thing of, okay, what's a software development process? Well, but really I'm just going to use that as a way for me to think about this program that I started last week and that I'm going to start working on this week. So this is the program I had from last week, and it's kind of a mess because, well, I was doing a live stream and not really having too much of a strong idea of where I was going. But this week, I think I want to refine what I'm trying to do a bit. So let's get into what a software developer might do. All right. So a software developer is going to have some kind of a development process. And generally that's going to be, they're going to have a list of things that they need to do. And that's often called maybe a product backlog. The product here is my Elegoo Smart Robot. And the backlog means that you haven't done it yet. So it's a product backlog. It's a list of things you need to do. So normally you'd put this in a nice, Excel spreadsheet or Trello board or something like that. But I'm not doing any of that. I'm just going to put it right in my program. So what's the list of things that I want to do here? Well, let's see. I'm going to put it as comments here. Oh, well, /star. That's my multi-line comment. If you've never seen a multi-line comment before, a lot of programming languages give you these with a /star and ending with a //. So it's very nice because you don't have to put a bunch of stuff in between. Now this IDE gave you another star in between, but it's not necessary. So product backlog. What do I want this thing to do? So I want to control it with an IR remote. Now, I kind of did that last week, and also Elegoo gave me a program to do exactly that, but I didn't really like it. It wasn't very controllable. And I think the biggest thing was, how do you control motor speed with like one of these infrared remotes that I'll show you here? How do you control motor speed with just buttons? And I guess there's a couple of different ways you could do this, right? You could probably punch in a number of motor speed or something like that, but I'm not going to go that way. But even before that, this is a list of requirements. This is not, or this is a list of, a backlog of things to do. This is not really a, how do we solve this problem yet? So I'm going to say, developer, I want you to figure out how to control motor speed with IR remote. Okay. And if you guys have any good ideas of anything else I should do with this robot, put it in the chat and I will figure out some, and I'll add it to this list. But this is what I really want to focus on this time. Let's see. So let's prioritize these. Well, so in programming, once you've got your product backlog, you got to prioritize it because you can't do everything at once. So here, I'm going to prioritize this by saying, well, we need to have full IR remote control, and then we can work on how to control the motor speed with an IR remote. So yeah, clearly the first one is a higher priority than the second one. And in real life, this will always be a negotiation between you and the person asking, or you and yourself, if it's for your own self. But you should come up with some kind of good idea about, well, does this come before that or that? And so then we should estimate how long these things are going to take. Now, I kind of cheated. I actually did this a little bit earlier, so I estimate that I will be able to do this within an hour. And I think I will have plenty of time. But in real life, you're going to want to take a look at this and be like, okay, I've got 2 hours to do this. Will I be able to accomplish this in 2 hours? Or, this thing will take 20 hours for me to do. Am I going to be able, how long is it going to take for me to do this? Or something like that. So in general, time is a resource, and you always have to be aware of that. So let's see. And part of the reason is because people have deadlines. You have to plan. So let's see. Now, we won't quite get to this. We may not quite get to this today, but after I do this work, some people will call this a sprint. How long does it take to program an FRC bot? Yeah, well, hey, it all depends on how much stuff you want to get done. If you want to get the bare bones done, not really that long. If you want to, get, add all the bells and whistles and have rocket launchers and stuff, it may take a little while. So yeah. So I'm going to start coding this robot, and in the program software development world, we're going to call that a sprint. It's a piece of time where I'm going to do some work, and I think that I can get all the work done within that piece of time. In this case, about an hour. At the end of it, I'll generally want to do a presentation or demo to my customer what's going on. In this case, I don't have a customer. The customer is me. So I'm going to do a sprint review, right? I'm going to review, well, did this actually do what we wanted it to do? And get some good criticism that way. Because in the real world, stuff actually has to work for the people you're making this stuff for. And at the end of that, then you also, if you have a team doing this, you're going to have a sprint retrospective to say, well, did we meet the customer's expectations or did we not? And should we, how could we improve the way we work for next time? All right, so that's it for my boring programming or software development type stuff. I'm going to move on to looking at more deeply about how this infrared remote works, because you may think that it's simple to just take a infrared remote and get your robot to do stuff based on it, but it's not really that simple, because it's not like you have a direct connection between your remote and your robot. There's like messages that get sent. So it's actually kind of tricky to figure out how you're going to interpret that and synchronize things. So let's take a look at the protocol here. Let's take a look at the chip first of all. Let's look at the chip. So this is the infrared chip that is probably on this Elegoo Smart Robot. It's an IR receiver. I think the one on mine in particular is TSOP 4838, and the idea here is that it's going to run on this 38 kilohertz carrier frequency. So what's actually going on here is the infrared remote sends out a 38 kilohertz signal, and in order to send information over that signal, it just turns the signal on and off. And then this chip receives that signal, looks for something at 38 kilohertz. So if you have something at like 37 kilohertz in the infrared range, it gets ignored. So it's looking at like 38 kilohertz from your particular remote, and then if it detects a signal, it turns on, and if it does not detect that signal, it turns off, I think, or something like that. Here's the actual circuit. There's magic. Look, I'm a programmer. This is all hardware stuff. But the gist of this is that I'm going to be able to, read the information off of the pin, because this one of these pins is going to be connected to the pin on my Arduino. And in fact, I won't even have to try to figure out how to intercept it. I will be able to use a programming library that's designed to intercept it. So the actual signal is, in this case, is the NEC protocol. There's like 5 or 6 different infrared protocols that are standardized, but who cares? The IR library, remote library, takes care of all of it. And so you can see, it's like here in this section, the signal gets turned on to say, oh, hey, there's a command incoming. And then here's the actual command at the end. And basically, then there's a repeater code that comes along. So if you hold down the button, this repeater code gets sent as well to say, hey, the last signal, redo that. So this is all really, really important for me because I need to now take the codes that are transmitted with each button press and interpret that. The way I'm going to do that is using this IR Remote Arduino library. This is really useful because I didn't have to write any of it. Why? Why cheat? Why create when you can steal, you know? So the idea here is I'm going to use this receiving with the IR Remote library code. Going to just paste this into my program. I've already done that from last week, and pull out the values. So let's see again how this all works. Let's see, So let's load up my Arduino sketch here. And because I've got some connection back to my computer, I'll be able to simply read off the values as the IR Remote sends them. So let me hook my Arduino back up to my computer, and it's going to tell me what values are being sent. So let's see. Take a look at. Here's this. See, I've got my handy dandy remote on my computer. Now you're not seeing this, but I'm pulling up the serial monitor, and I can press a button, and I think there you might see there's a light flashing a little bit, but the idea. Let's see. Oh, hold on. Let me program it. Give me a second. Code's compiling. Uploading. Done. All right. Clear output. Yeah, sorry, I had the program I was working on earlier. So let's see, I'm going to hit a button, and then let me show you the output. I got a number, and that number, well, I think that's the continuation code. So let me try this again. So yeah, this number, I just hit the one button on my remote, and I got a 407-358-4965. That's the code that got transmitted, and then this is the continuation code saying, oh, he held it down for longer. So if I press it and hold it down again, you see I'm going to have tons of continuation codes. So that's kind of what I got to do. So let's think about this for a second. I need to make this code respond to this and start up a motor corresponding to that. So in this case, I actually want to connect it to the front, back, left, right buttons. So when I get a front, back, left, or right code, I want to start the motors going either front, left, back, or right. But you might think to yourself, well, what about stopping? That's a good question. I could do a couple things. You know, the normal thing would be you take your finger off the button and it would stop. But how do you know? Because there's no code transmitted when someone takes their finger off the button. We got to figure this one out. So, but anyway, let's just get coding because that's the fun part. So from last week, I had written a setup method to set up everything. I've got some defines here to say, okay, these are my pins. I've got some stuff for decoding the results, and this is the pin that I'm actually receiving the infrared signal on, and set up some. So what I really should do here, before I get too deep into it, is start to comment it. I know, comments are boring. But you know what? It's important to remember what you're trying to do. So here, I was able to say, okay, these are the motor control pins. Here is my IR, let's see, IR stuff. I don't know what to say. I've got this temporary value, you know, I'm just going to leave that for now. This comment is pretty good. You know, set up everything as outputs. This is a good comment here. I can add a comment here saying start IR library. It's gonna that'll tell the library, hey, start listening for infrared codes. I just copied this, so obviously this is garbage comments because those are not correct. So I've got a method here, or a function in this case, called forward. It returns nothing, and this is the code inside. It's got so it's going based on what I talked about last week. Is it going to drive the motor forward and actually drive it at 100 out of 255? So this is going to drive it forward. You know, I think it's fairly obvious what it does, but you know what? Why don't I comment it just for the heck of it? I'll just comment this one. I'll say drive, I think this is the, yeah, where it says left side. Left side and forward, drive right side forward. And I don't think I need to comment for everywhere else. I got this break function that's going to stop it. This is going to basically tell everything to stop. And actually it's a break to stop. By setting all these pins high, it tells it actually apply power to stop your car. So I got a forward and a right. For completeness, I think I'm gonna go and, let's see, let me finish commenting here. So let's see, put my main code here. I don't think I need this anymore. I should probably comment what this is doing. So this is what I'm doing here is basically if you get a result, then figure out what to do. So let's see, check if we got an IR code. That sounds good. Here we're going to say send code back to computer for debugging. Now, if you're more familiar with this, obviously you don't need to put all these comments here to say, okay, you're going to send the code back to the computer for debugging. This is really common. You know, it's a really common way of doing debugging. You're probably going to remember. Here I'm going to say, you know, save code and resume listening for codes. Because this library it'll give you one code and then it'll wait for you to tell it to listen for the next code. So in this case, you actually have to tell it listen for more codes. So here is where we can actually say, you know, figure out what to do with code. Simple enough, I guess. So last week I coded it to if someone pressed this button to go forward, wait for 250 milliseconds, and then stop. So I guess I'll leave that for now. And that's pretty good. That looks like some good comments. So that's all the code. And then we need to go back to remembering what we were trying to accomplish here, which we have up here. Infrared remote control. So we want to control this using the IR control. Now, obviously this only is listening for one code right now. So, which is go forward for 250 milliseconds and stop. It doesn't seem very useful. So let's add the other, you know, left, right, and back. I'm gonna make some different methods here that are going to do left and backwards. So I'm just gonna copy the existing ones. I'm gonna take forward, copy that one, and then just start renaming this to make the backward function. Backward. So drive left side backward. And while I'm thinking about comments, I'll change that one to also be backward. I still want to enable left at say 100. That's fine, but I got to reverse these now. So because this represents the direction, and then reverse these as well, high and low. Okay, so I think I've gone and made my backward method or function. I keep saying method. Function. And I think I've reversed the things correctly to make it do the opposite of forward. So let's do right. Well, do left as a copy of right. Now I didn't comment it, so I don't need to change comments, but I do need to change the name, and I need to change the directions. So I'm going to drive the left side, well, backwards. So that's going to be this way. And drive the right side forwards, yes. There we go. So I realize this kind of seems like magic, but you know what? Once you got the left or the right and forward figured out, obviously backward and left is just the reverse of that. So let's see. So now we've got the functions we could call whenever we want to. And now we can listen for different codes. Now I actually forgot what the codes are. So thankfully I've got it telling the computer what the codes are. So let's start this thing again. And I can use that serial monitor to go and listen for the codes. So I'm going to do forward. So I think it's funny about these things. There's actually like an alt code. And you saw this code here. I pressed forward, and I got 5316027. I think there's somehow two different codes that get sent. So two different possible codes. So I'm going to record that for forward. In addition to the 16 blah blah, there's a 5316027 code. And then also that continuation code, or repeat code, I'm going to call it repeat, is just that code. So let's do left. It's going to be this code. Yeah, this is not the scientific way to do it, you know? Yeah, that is left. Okay. But you know what? It's a lot easier than trying to figure out, to look it up and, you know, come on, I'm a programmer. Okay, that should be right. I don't need to know the theory of everything. And backwards is going to be, okay, wait, that one, I think, yeah. I also got this code, so I'm going to copy both of them. So I think they're, like I said, some of these seem to have alternate codes, and I don't understand exactly why one code gets sent instead of the other. But there we go. That's our output from this program, or from that infrared remote. So how are we doing on time? I said I had estimated, right? So I'm 26 minutes in. That's not too bad. All right. So let's let's add another comment here saying, well, I'm going to, this one's forward code. So when you press the forward button, it's going to move forward, delay 250 milliseconds, and stop. So we're going to do something similar with the other directions as well. I'm going to copy that code because it's just easier to take existing code and rewrite it. And I'm going to say, well, if it's this code instead, I'm going to do backwards. And I'm going to say if it's, you saw it, so you remember how I got the two codes? Well, I'm going to put both of them here. I'm going to say if value is equal to the first one or value is equal to the second one, then go backwards. So I'm going to change this to be backwards and then to stop as well. And let's do something similar for left and right. So I'm going to copy the forward code again, add an else to say that, say left. So if the code is that, then move left, wait 250 milliseconds and stop. And this time I'll copy the left code and make it the right code. Now I think I did pull out the other codes here. So I think, why didn't I add them just for the heck of it? Well, yeah, let's see. So for forward, the alt code was this, double equals. Some people actually use a little trick, because it'll work in either way. If you to do a double equals here, to put the constant value first when doing a comparison, because if you accidentally do a single equals and try to compile it, it will not compile properly. Whereas if you did it in the other way, like this, it will still compile. Although in this case it's backward and not backwards, so that does not compile. And this can screw up your code because you're not comparing, you're not saying is value equal to this, you're saying is value, you're setting value to this and then saying did I successfully set the value, which is not what you wanted. So I really should do it more like this, but I tend to aesthetically like this style better, so whatever. Let's see, the other left code I think was this one. And the other right code was this one. So now if I get, like I said, I don't remember exactly why those codes come in one versus the other, but that's how it'll work. But now either one comes in, it'll be fine. Okay, so I think I've got my code going. It compiles. No, it does not compile because I made the mistake. See, it's already catching bugs. So now my code compiles, and let's upload it to the robot and see if it works. Okay. So I'm going to move forward. It's not working. All right, what did I do? So let's see. So clearly, it's getting the value. That's not a problem. But then it's not actually driving it. So, did I break it? All right, let's see what I did wrong here. Let me just try and drive it, make sure this code works correctly. Let's see if that actually works. So when I start it now, well, it's actually just going to drive forward. Oh, I know what I did. I didn't actually turn it on. That would help. All right, let's try this again. I think that's the issue, is that the battery powers the motor controller. And there we go. Let's switch cameras here. All right, see, I press okay, let's bring this all into view here. I'm pressing forward, and it just runs, even though I hold it down, it just runs for 250 milliseconds, and that's it. Left, same thing, right, and back is, there we go, there's back. Not sure why back is being finicky. Reverse. Oh, because I have the wrong code. Yeah, I think that's right. All right. But yeah, I read out the codes from earlier and looked at some of the documentation, and yeah, I think I had got them wrong, the wrong codes. So let me recode that, or reprogram that. Uploading, and then I think back should work better now. There we go. Okay. So let's go back to our tasks here. I can control it with an infrared remote control now. That's done. Great. But it doesn't really work very, it's not very usable, is it? Right? So if I go and put this on, say, my desktop here, unplug it. Okay. You know, this is not very controllable, is it? Come on. That's all it moves. Not really as controllable as it should be. Oh. Apparently if I hit left or right, they both go left. So I gotta fix that code too. So let's start thinking about how we can make this more controllable. And some of it's going to have to do with the way that we're going to listen to the infrared commands. So what I want to do is actually start to think about, well, we've got, we can start doing things when we get the right code. But then we should actually start to, we should leave the motors running until someone, the guy lifts off the button. But how do we know when he lifts off the button? Or she? How do we know when she lifts off the button? So we're going to rely on this loop to go and check that and to decide that if, kind of have a dead man switch almost. Leave the motors running, and if you don't get a code, then actually you need to stop the motors. So let's do that. We're going to leave the motors running, and then if we don't get a code within, say, 200 milliseconds, then we're actually going to stop the motors. And part of the reason I'm choosing 200 milliseconds is that you see on this chart here, it's saying, oh, there should be a code every 110 milliseconds. So 200 milliseconds is plenty of time and fairly responsive. In fact, I could probably make it like, 120, 130 milliseconds and make it pretty responsive. But I'm just going to stick with 200, I think. So let's see. So what I'm going to make it, I'm going to take this stopping part out. We're not going to stop, right? So now if I hit one of these, hit a button, it's just going to run. What just happened here? It's not happy. There we go. And obviously this is not going to be usable anymore as really a car. Done uploading, because I'm going to hit this and it's just going to keep running. Not really very useful. In fact, I'm going to shut it off because it's going to be annoying. So now we need kind of our dead man switch, that if you don't get a code within 200 milliseconds, then we need to stop it. And how do you do that? Well, I think the easiest way here would be to record the last time that we got a code from the infrared remote. So we're going to record that time. We're going to have a new variable up here. We're going to call it an unsigned long last IR code time. And we're going to just initially set it to 0 because it's always good to initialize your variables. And down here, we're going to, every time we get a code, we're going to set that. So here, if you're in this block of code, you got a code. You got a code from the infrared remote. So I'm going to set that to that variable now. And there's a method called, or a function called millis that gives you the number of milliseconds since, I don't know, I guess you started the robot. And that will give you, and then we can record that, or use that to mark the time. Because we can call millis again and figure out how much time has gone on for our dead man switch. So if, and by dead man switch, I really mean like if you have, think of like a train and like a train conductor. If the conductor somehow has a heart attack, or no, not conductor, an engineer. Say the train engineer has a heart attack and you got this big long train moving automatically. You probably want to like stop the train automatically if there's no input from the engineer. So that would be a dead man switch. Or like if you've ever pushed a lawnmower and it's got that lever on there where on the handles where it won't run unless you're holding down the lever. Well, that's a kind of a dead man switch. It's just for safety. In this case, we're using it to stop the robot. So I'm going to calculate another variable. I'm going to say unsigned long. I'm going to call it like time since last IR code equal, and I'm going to set it to, let's see, the current time. I'm going to pull out, and I'm going to subtract out the last IR code time. So that's going to give us the amount of time since we last got a code. And I'm going to say if this time, the time since the last code, is greater than 200 milliseconds, then we're just going to stop. So I think I called it stop, right? Or I called it break. All right, let's break. All right, let's see how that works. And then I got to reset it. Oh, and yeah, I gotta reset, I think, that time. Well, yeah, let's see how this works. Okay. And I think it's not working. I think part of the problem is, oh wait, of course it helps if I turn on the power, right? There, how about that? There, I think that's pretty good. So now it'll be much more controllable. There we go. So every time I release the button, it stops. How about that? I think that's pretty good. But I have not really implemented my speed control. So it's much more controllable than before, but there's no speed control. So I think what I'm going to do is, I think the longer I hold down the button, the faster I want it to go. And I think this actually makes a lot of sense because if you're not going to need full power right away, first of all. And if you're trying to do fine motor control, you're not, like, say I want to turn left, I just want to do this. But if I want to just spin the thing, I should be able to just spin it at full power. So the longer I hold down the button, the more power I want it to have. And here, obviously, I'm starting at 100, which should be just barely enough to overcome static friction and the internal friction of this drivetrain. But then what I'm going to do is I'm going to ramp it up. So kind of similar to this, let's see, to the time since last IR code thing. I also want to record time since the last command. So that's going to give me the time since the he or she who started driving it press the button. So I'm going to record that. Unsigned long, let's see, last command code time equals 0 here. So I'm going to record that now. And then I'm going to record, copy that variable name, because this doesn't do autocomplete for me. And so every time we get one of these new codes, I'm going to record that we got a code at this time. I'm going to just copy this line. And I know I'm not commenting it, but that's kind of because in general, when you start programming, you know, you kind of get these ideas and you want to just get them out. And you don't want to be bothering with, you know, putting code in there. Now, there's styles of programming that ask you to put the comments first, but I'm not going to do that here. So let's see. I'm going to. So I've got the time that I got the command last, and all of these start off with a power of 100. So I'm going to add some code up here to calculate unsigned long time since last command code. I'm going to go and calculate it just the way I did the other one. And I'm going to say if time since last command code is greater than, say, 200, let's do 250 milliseconds, then let's ramp up the power. And I'm gonna mess around with these analog write commands here. Now I probably should break this into a separate function, but for now I'm just gonna make it nice and dirty. So I'm going to increase the power here to 150 instead of 100 after 250 milliseconds. And then let's see. And actually, I'll put another if here, make this one an if else, and say after 600 milliseconds, let's make it 200, something like that, 200 power. And then let's do the same thing. Let's add a, say after, what do we want? 750. Let's make it pretty much full power, 255. So let's look at our code here. We're going to calculate the time since the last command. And if that was greater than, if you had more than 750 milliseconds since the last command, make it full power. If you had more than 600 milliseconds since the last command, make it 200. And if you had 250 milliseconds since the last command, just make it 150. So I think there's going to be a problem with this code, but let's try it. Because why not? It's always more fun. Oh, come on. Why is it doing this to me? Oh, well, it would help if I plugged it in. All right. Yes, I know. I'm not plugged in. Let's try that. Okay. Let's see how badly this performs. Right. Actually, I think that worked correctly. You hear it, the sound going up? And actually, let's try that on my desk here. So you see what it's doing. If I just press, what is it doing? Why is it not happy? See, if I just press the button a little bit, I get good control. Okay. And then if I hold the button down, it goes full blast. I think that's pretty good. Yeah, how about that? I think that worked out pretty well. Yeah, I think this is pretty clever. So yeah, now let's take a look back at my requirements here. At my, you might call them user stories. Control motor speed with infrared remote. We figured out a way to control the motor speed with the infrared remote by just holding it down and making it go faster the more you hold it down. And we made it more controllable by having kind of a dead man switch where if it doesn't receive any more codes, it just kills the robot. So yeah, I think this is pretty successful. I like this. I really like this. So, what do you guys think? Pretty good? So, I think this is about all I have for tonight. So thank you for watching. If you have any ideas, please let me know. Oh, you know what I should do? I should show you some debugging about, to show you exactly how this is working. So let's add some debugging here where we send back to the computer every time we increase the power. Let me put this back on my stand. Serial.write print line. That's what println means, right? Increase, let's see, power is 255. Let's copy this line to be here. Okay, power is 200. This one, power is 150. And this should help us see when this, of course it helps plug it in again, right? This should help us see when it's making these decisions. Compiling sketch. Let's open the serial monitor. Oh, port busy, I'm sorry. There we go. Oh, it's kind of outputting a lot of this. But there we go. Well, you can see, yeah, this is kind of part of the issue, but that's fine. It's not perfect code, but you can see how it's increasing the power the longer it goes. So yeah, this is pretty good. So I think that's about all I have for tonight. Thank you for watching, and hopefully I'll get some more people to watch next week. So thank you, and everyone have a great night.